Hello students, in today's session we are going to discuss the angular velocity. What is this angular velocity? Before going to the angular velocity or the definition of the angular velocity, you should know what is an angular displacement. Angular displacement. So to understand the angular displacement, what I take a circle or a circular path, I can say. Just imagine this is the circular path. And this is a radius vector. This is the vector, radius vector. Radius vector means a vector originating from the origin, that is the center of the circle, and the point on a circumference of a circle. So if you take this as a radius vector, you know this is the radius also. We are representing as a vector. So this is the radius vector. So this radius vector, if it rotates, if gets rotated, I'm rotating this radius vector, then what happens, if it is the tip gets rotated, that means the radius vector, if you are rotating, then how much angle is turned by this radius vector? How much angle is turned by this radius vector in a given time? That is called as an angular displacement. So this angle d theta is called as an angular displacement. So I'll write here d theta is angular displacement. We have linear displacement also. In the same way, the angle turned by the radius vector in the given time, that is called as an angular displacement. So I hope it is clear what is an angular displacement. Now what I do here, students, how we are going to define angular velocity. The main topic of today's session is angular velocity. How you are going to define angular velocity? This is the angle turned by the radius vector in given time. So the rate of change of angular displacement, I repeat, the rate of change of angular displacement is called as angular velocity. And this angular velocity we denote it by omega. So let us see the definition on the board. So here, what we can say, the definition, it is defined as the rate of change of angular displacement of a particle. You can clearly see what is an angular displacement. So angular displacement is the angle turned by the radius vector. So how much angle is turned? So it is d theta. And the angular displacement, when the particle is moving completely on the circumference of the circle, then this angle, it will be what? 360 degree. So angular displacement will be 360, that is 2 pi. Now let us see what is the relationship that exists between the linear velocity and the angular velocity. Students, the particle is moving, and suppose it is describing the displacement. How much displacement it is? Just ds. Just I am considering a small displacement ds. I am considering small displacement ds. Yeah, see the displacement ds. Now students, it is a very small. Just for you to understand, I'm drawing like this, but it's very small. So here ds is the small angular displacement, and r is the radius of the circular path on which the particle is moving. Suppose this particle is moving with the velocity v. That is, the linear velocity is how much? V. Now students, you know what the definition for angle. Angle is defined as the ratio of arc to the radius. So I'll write that only. Angle is equals to the length of the arc by radius. This is the definition for the angle, arc by radius. So how much is the angle here? That is d theta. This is d theta. That is equals to, what is arc? Arc, how much it is arc? Suppose the particle is moving from A to B, and this is the center. So what is an arc here? AB is the arc. And you can see the radius is how much? It is r. Now this is d theta. What is AB? AB we have considered as a small displacement. So therefore, this I can write it as ds by r. Now just you cross multiply. ds is equals to r into d theta. I'm just cross multiplying. Now what I'm doing, I'm dividing by dt on both the sides. So what I do, dividing by dt on both sides. So what we are getting, if you divide, let us see. This is what ds by dt is equals to r as it is d theta by dt. Now, what is this ds by dt? That is displacement by time, rate of change of displacement with respect to time, or displacement by time, that is velocity. This r as it is. What is this d theta by dt? We can see d theta by dt is the angular velocity, and that angular velocity we are denoting by omega. So what I do here is v is equals to, this is r and this is omega. Now students, if you want to write the same thing in vector form, so how to represent the relationship that exists between the linear velocity and the angular velocity? So in vector form, it will be v bar is equals to omega cross r. I hope you have understood what is the angular velocity and what is the relationship that exists between the linear velocity and the angular velocity. Students, let us move to the problems based on the concept of the relation between the linear velocity and the angular velocity. The first problem on the board is, you can see here, a car is moving in a circular path with a uniform speed v. Find the magnitude of change in its velocity when the car rotates an angle theta. So here you can see clearly it's a uniform speed. It's not the uniform velocity. The reason here is when the car is moving on a circumference of the circle, the direction of the velocity gets changed. So 100% velocity changes. So saying that the velocity is constant when the car is moving on the circumference of a circle is meaningless. So the magnitude of the velocity, that is the speed remains constant always in uniform circular motion. It's very simple question if you remember, if you can understand it, and it's very important also. So let us see how we are going to solve it. So what I do here is I just take a circular path here. This is the circular path. So here initially, suppose this O is the center, A is the initial point. The initial velocity here you can see clearly initial velocity, this is v. This is v. Magnitude, just I'm taking the magnitude. It is moving with the velocity v at this point b, at the point A. Now after some time it has moved to this point. Suppose this point is b, and at this also it is having the same speed, not velocity, speed is same. And if you join this and this point, as per the question, the angle is rotating is how much? Theta. So what I do, I take here as theta. So what the question says, find the change, find the magnitude of change in its velocity. So how to calculate the change in its magnitude? That is very simple, provided if you know the parallelogram law of vectors. So we apply that, but before going to that, let us see what is the angle between these two velocity vectors. Or see, this is the first one, you can see clearly, and this is the second one. This is the first one, and this is, you can see clearly, this is the initial direction and this is the final direction. Now students, this is v means this is also v, and if suppose you consider this is as a vector, this is also a vector, and if this is theta, then this is also theta. That means two velocities are there, and the angle between these two is theta. So if I ask you what is the change in the velocity, so many of the students will say the change in the velocity is zero, but that is wrong. I'm not saying that. What I just try to understand what I am saying. See, यहाँ पे मैं क्या बोल रहा हूँ बेटा, अगर आप suppose initial value v लेते हैं, final value भी v लेते हैं, then what is the change? Zero. No, it is not zero. The reason here is they are not in the same direction. One direction is like this, other direction is like this. So saying that the magnitude, that is the magnitude of change in its velocity is zero, that is meaningless. तो हम इसको कैसा find out करते हैं, आइए. तो यहाँ पे मैं लिखता हूँ बेटा, that is change. How to find the change, you know, that is v2 minus v1. I'll write like this. That is the resultant velocity is equals to v2 minus v1. And as per our situation, this is our v1 and this is our v2. Both are the same. Now, these are the vector form. So what I do, magnitude, here also magnitude. So this is v only. I'll write here, this is v, and this you know how to calculate. This is under root of v2 square plus v1 square minus 2 v1 v2 cos theta. This is the parallelogram law of vectors what I am applying. Now students, if I take, this is under root of, this is v2 square. What is this? V2 and v1 both are equal to v only. I'll write for your understanding here. V1 is v. Now if I take the magnitude of this v1, it is just v only. That is v bar hum likh rahe hain v. Okay. Now in the same way, what is v2? That is also v. If I take the magnitude of this v2, that is also v. So writing that modulus sign, or just you can write v1 as v and v2 as also v. It all means the same what I have written here in different forms. Now students, what is v2? V2 is v, v1 is also v. So here I'll write this is v square plus v square minus 2 into v cos theta. That is equals to under root of, this is 2v square minus 2v square cos theta. So 2v square common, this is 2v square, 1 minus cos theta. So this is the answer what we are getting, 2v square into 1 minus cos theta. But this answer may or may not be mentioned in the options. So इसके लिए हम थोड़ा सा trigonometry apply करेंगे बेटा. So what is that formula we are going to apply for trigonometry? Pay attention. And this is the important one. I request all the students to take this as a very important note. 1 minus cos theta is 2 sin square theta by 2. Another formula is also there that we come across, 2 cos square theta by 2. Both are there in trigonometry. 1 minus cos theta, 2 sin square theta by 2, 1 plus cos theta, 2 cos square theta by 2. Now under this, if suppose I want to replace this 1 minus cos theta, I can replace by 2 sin square theta by 2. So here under root of, this is 2v square, and this I can write it as 2 sin square theta by 2. The same thing I can write it as 2 into 2 4, and this is what, v square sin square sin square theta by 2, and this gives us, this is 2 and this is v and this is sin theta by 2. Hope you have understood the question along with the solution. Let us move to the next problem. The next problem on the board here you can see, what is the linear velocity of a person at equator of the earth due to its spinning motion? Now here you can see clearly what the question asked. A person is there and he's standing at the equator, and you know earth spins means earth rotates. So because of the rotation of the earth, what is the linear velocity of that particular person who is standing at the equator? So just now we have seen the relationship that exists between the linear velocity and the angular velocity. So how to move with that? Let us see. You know v is equals to, that is linear velocity is r omega. Now this r as it is, what is this omega? Omega is the angular velocity, and this angular velocity in terms of the time period, how we can express, that is 2 pi by t. This is the standard formula, that omega can be expressed as 2 pi by t, where t is the time period. Now let us go with r. What is the r? Radius of the earth. Radius of the earth is how much here? 6,400 kilometers. So I'll write the same value, 6,400 kilometers. Student, this is kilometers means 10 power of 3 meters. I repeat once again, why I am multiplying by 10 power of 3? The reason here is that is given as 6,400 kilometers. Kilometers I am converting in meters. Now students, this is 2 pi as it is. What is this t? T is the time period of rotation of the earth. Now, what is the time period of the rotation of the earth? I'll take here. That is, 24 hours. 24 hours means this is 24 into 1 hour is 60 minutes. And students, 24 into 60 and 1 minute is 60 seconds. Why I am expressing in seconds? The reason here is, as SI unit of time is second. So therefore, we are expressing the answer or the time period, I can say, in terms of seconds. I hope it is clear. We cannot directly substitute in terms of hours. R is not the unit of time. No doubt, time is expressed in terms of hour, minutes, but SI unit of time, it is just seconds. Now, students, This is how much if you multiply this 86,400 seconds. If you multiply this, the value will be 86,400 seconds. So that value I'm writing here 86,400. So if you can see this two get cancelled, this and this get cancelled. 2 1 times 2 4 3 2. So how much it is? 4 6 4 0 0 0. That is 3 zeros into pi value is 3.14 divided by 432. So if you multiply this with this one and divide it by 432, you will be getting the answer 465.5 meters per second.